All right. Hello. So I've titled this video English to Math, but the idea that we want to talk about is we want to talk about how to start with a sentence and translate those sentences to math expressions or math equations. Okay, and just as a quick review too, this was in the last video, but it's a very important distinction. It's very subtle, especially once we get into deeper things, it's easy to forget. But the difference between this word expression and this word equation. So an expression is just some combination of numbers, variables, and operations. Okay, and then an equation is a statement that two expressions are equal, and that key thing there is equal. And so a very basic way to think about it is that with an equation, the problem comes with an equal sign, okay, like that. But with an expression, the problem doesn't come. So we'll say it positively. The problem has no equal sign in it, as given. Now remember, with expressions, we usually say we have a chain of expressions that end up being equal to each other. But as far as how the problem starts, with an expression, there's no equal sign. There's only numbers, variables, and operations. But an equation is a statement that two expressions are equal. So two examples of an expression. Here's one, 2x plus 3. Okay, that's just an expression because I have these numbers, 2 and 3. I have a variable, and I have operations. Remember, I have a multiply there, and I have an add there. But there's no equal sign. Okay, I could just as easily remember using exponents as an operation, so I could have x squared plus x as an expression, but again, there's no equal sign. And then for an equation, it's that the two expressions are equal, so if I wanted to get an equation, I could take that first expression and set it equal to the second expression, and then that is an equation. Okay, and learning how to translate sentences into math is a very big math skill. At first, they're just going to seem like silly textbook problems, but probably about 70% of algebra-related word problems simply involve translating some given information into a math equation or expression. So it ends up being a really important skill, and we'll talk about doing it from application standpoint in the next video. All right. So anyway, the key thing to translating is look for keywords. Okay. Now, to the most basic one is think about how you would say this: 2 plus 3. Now, we usually say 2 plus 3 equals 5. Can you think of another verb that you could say here? You could say that 2 plus 3 is 5. Okay. Key thing is there that word is, so you can see I've replaced the equal sign with the word is, and that is all by itself, and I'll explain why I point that out in a moment. Okay, but the first key word to realize is that the word is by itself. Okay, we got to think about verbs a little bit, and I'll point that out. But the word is by itself, that translates to an equal sign. Okay. Now the thing is, we got to get into a little bit of English and grammar to understand why I say by itself, because is sometimes a helping verb. All right. And so we'll also see phrases like is added to, and in that case, is helping the verb added, and so then it's not by itself. Okay. So that's the basic one. Now. For the others, we got to think about the individual operations and talk about keywords for some of the operations. All right, so let's think about some of the keywords whenever we're adding. So a lot of us know we say something plus something else. So plus is a keyword. All right, a more formal kind of word for for adding is to do a sum. Okay, sometimes people use the word total. All right, and then added to is an important one, an important phrase too. And the word added to and subtract from end up being important because you need to look at the order that the things are written in and think about how that translates, which we'll deal with in a moment. Okay, and so we get that. Sometimes also we might say something is so much more than another one. So sometimes we see this word more than. we won't see that as much as we can early on. Okay? You folks that are in my class too, there's a summary table of these phrases on page 4 of your book. Okay? And then, the keywords for subtracting. Think about some phrases that that indicate that you're subtracting things. And so minus is a keyword, kind of the more formal word that's equivalent to sum, but for subtracting is the word difference. Okay, like that. And then subtracted from. You got to be careful with that one because you got to think about the order. Like I say, I'm going to explain that in a minute. All right. And then sometimes more than and less than, they can be expressed in different ways, but sometimes from the context you can tell that that you're subtracting and you're not using a less than sign. Okay. And so now we get into the keywords for multiplying. All right. And so, of course, we know that the word times indicates multiplying. The more formal word is product, okay, and then multiplied by, okay, like that. And then there's a special one that we use too often. We'll use the word twice. Think about what you would think the word twice means, and that means multiply by 2. Okay, and so you're not squaring, and that's going to be an important thing I'll have to point out a few times. You got to be careful about saying something squared, or if it's multiplied by 2, you got to think about the operation going on. Are you doubling something, or are you actually multiplying the thing by itself? And then there's another word for multiplying that deals with fractions, and at the end of the video I'll explain this a little bit more. But the word of actually indicates multiplying. So this is multiplying whenever you're dealing with fractions or decimals. Oops, I almost wrote of there. So, or decimals. Okay? Like that. Okay, and then there's some keywords for dividing. I just ran out of room on my last slide. I tried to move things up, but they didn't stay together. I didn't like that in the last video. But anyway, so there's some keywords for dividing. There is, sorry about that shaking. There's the phrase divided by, of course. Okay, that more formal word would be the word quotient. Okay, another word for it is ratio. It's the key. It's equivalent to quotient. Sometimes we say the quotient of two things. Sometimes we say the ratio of two things. All right, and those are the basic words that we use for dividing. Sometimes we use the word per. PER, but you got to be really careful with that and how things translate with that. Okay, so those are our basic set of words right there. And sorry they're not all on the same slide, but hopefully you're taking notes. Okay, so before I get going too, I want to point out those more formal words. So let's just make a special note on, you'll either see the word sum, difference, product, or quotient, and again, sometimes people will say ratio there. Okay, but in the words and the phrasing for these problems, it'll be one of these 4 words. It'll say the sum, or it'll say the difference, or it'll say the product, it'll say the quotient, and then it'll say of, and it gives 2 things. Okay, but the key thing is those 2 things are going to be separated by the word and. All right, and so these are those end up being the 2 things that you either add, subtract, multiply, or divide. And so look out for that. And the key thing is, because most things we can translate directly, but whenever we have these kind of phrases right here, what we got to do is identify the correct operation for the word. And then locate that word and that tells you what 2 things you would do. So that all sounds a little cryptic, I just realized. So let me just show you what I mean here. And so say I tell you to translate, let's do a couple of these. One, the sum a number and 6. Okay, like that. So here's this word sum, so that means addition. Let me put this on this slide too if you forgot these phrases or you're not aware of them. So, okay, so those are the operations that go with each one of those words. Okay, and so on this translation right here, we have a sum, so we know we're going to be adding two things. Okay, like that. And then it says, here's my, well, let me point it out this way. Here's the word and. So I'm adding this and this. So hopefully you see that the right side of that sum is 6. Now this is just talking about a number. We don't know what that number is. So what do you think we would use for that? We need to use a variable. Okay. In the bigger picture, you can use any variable name you want. It's very common in general context where you don't. It's just basically a book problem without any context to it. Very often we'll use the letter X. Okay. Also be aware on these types of problems. This is the answer to that problem. We don't do anything else with it. All we're doing is translating that into an expression. Okay. Let's do one more, slightly more complicated one. Say I said to translate the difference of twice a number and 10. Okay, like that. So keywords to notice here. First of all, the word difference, although I didn't spell it right. Geez. Difference. Okay, but we're doing the difference of twice the number and 10. So we're doing a difference, and so that difference, I don't want to use arrows, they'll end up crossing. So this word difference tells me that I'm going to be subtracting two things. And see, there's this additional stuff in here that might confuse you, but the key thing is to identify the and there. There's the and. So what am I subtracting? I'm subtracting this and I'm subtracting that. And so let me separate two parts out of it. Here's the first part that I'm subtracting, and then here's the second part that I'm subtracting. Okay? And so we're subtracting the 10. And then how would we write twice a number? Remember, twice means 2 times. And so I would have 2x, like that. Okay? So look out for those basic phrases, and they can be a little bit tricky to translate, but just identify which operation you're doing from that word. There will always be that word of, and then the two things that you're performing the operation on are separated by that word and. Okay, and another quick note about quotients, okay? And so remember the word quotient, that means divide. The thing is besides in arithmetic classes, I never use the divide sign. It's kind of odd to me whenever we use that. And the reason for that is to remember that a fraction is division. So whenever we usually write division, especially in algebra and above, we usually use fractions to indicate that division. We don't really use that division sign. So just as a quick example, tying into the examples from the previous slide too. So say I say the ratio of 6 and a number, like that. Okay? And so here we have that word ratio. Remember, that's the same thing as the word quotient. Okay? And so that tells me that I have a divide, and so I'm going to be dividing two things. Okay? And then here we have the word and, so this is indicating the two things that I'm dividing. So what am I doing? I'm doing 6 divided by x. Okay? Like that. And just remember, whenever they refer to a general number, we're just using that variable right there. The thing is, people in math, especially once we get in beyond algebra, we usually don't use that division sign. And so the way we'll really say it is 6 over x. And just remember that fraction bar means divide right there. Okay, so this is really the way, the more standard way to write it and the way I would recommend doing it. Okay, now one thing to be aware of, whenever you're doing an operation with adding and multiplying, it doesn't matter what order you add or multiply in, meaning that if I have 2 plus 3, that's the same as 3 plus 2. Same thing with multiplying. 4 times 5 is the same as 5 times 4, okay? But subtracting and dividing, for subtracting and dividing, the order does matter. That 10 minus 6 does not equal 6 minus 10. Those two are opposite in sign. And same thing, 10 divided by 2 is not the same as 2 divided by 10. So with subtraction and division, order matters. So that's an important note in and of itself. It probably doesn't tie into what I have titled on this slide, though, and there's a reason for it. I just wanted to point that out because with added to, the thing is, with both of these phrases, in essence, the order that you write your answer matters. Okay, but in the first one, I'm sorry, since you're adding, in terms of being correct or not, it ends up not affecting you because the order of addition doesn't matter. But with subtraction, it does. So you've got to think about the order that things get put in whenever you fill in these two slots here, the slot to the left and slot to the right. So let me explain this with added to. So let's look at this through an example. Say I tell you to translate 7 is added to a number. Okay, and here you got to think about the actual English here and what order it's actually saying here is that it's saying, yeah, there's this 7 that's written first, but it's added to a number. Okay, and so think about how addition actually works. We have 3 plus 5. We think about starting at the 3 and then adding on the 5, right? Like that. And so I hope you see what I'm trying to get at here. This 7 is what's being added on to something. So the completely correct way to say this is you're starting with the x and then you're adding the 7 on. Okay? But because the order of addition doesn't matter, you would get the same result if you accidentally wrote that out of order. Okay? Like that. All right, but technically it's slightly incorrect because of what this verbiage is indicating. Now this ends up being important with subtraction though, okay, like that. So let's just keep those same two phrases, but let's say 7 is subtracted from a number, okay. So see, if you're not thinking here, and you just say, well, 7's written first, so I'm going to say 7 minus x. Maybe pause if you need to and ask yourself, why is that not correct? Okay, and so this actually is not correct as an answer. Okay, and the reason for that is it's the same as with this. We got to think about what the wording is saying. 7 is subtracted from, so 7 is what's being subtracted. And then it's subtracted from this unknown number. So the actual correct answer there is x minus 7. And see, the key thing is, in this case, it's not the same result. That does not equal 7 minus x. So that would actually be incorrect if you wrote it in the wrong order. Okay, now there's another big set where the wording gets tricky. Okay, and this one's hard and sometimes difficult, and I even make this mistake sometimes if I'm just writing to myself. And see, that's one thing about what we're about to talk about is when you're writing to yourself, you know what you mean, okay? But when you're writing to someone else or you're reading from someone else's work, you might not know their intent, and so we need to be as careful as we can and actually adopt some kind of rules or conventions, just like order of operations, so that we understand what someone means, okay? So I don't know if you see what's tricky about this, but 5 times the number increased by 8, okay, like that. The problem is there's actually 2 interpretations because first of all, there's 3 things going. There's 3 numbers here. There's 5, there's this unknown number, and there's 8, okay, and there's 2 operations here. There's times, that one's obvious, it's a multiply. There's increased by, that actually means plus, okay, like that. And so so we have these 2 operations. So we have a 5, we have a times, we have this unknown number right here, so we'll say x, and then we have a plus 8. Okay, and this kind of ties into order of operations. Okay, but it depends on how you read that sentence in terms of how you would interpret what that person is trying to say. And let me try to illustrate this. Are they saying 5 times a number, then increased by 8, okay, in which case this one right here would be the answer to that, okay? But there's a different way to interpret all of that. Okay? Are they instead, I just messed up. Uh, so are they instead saying, are they instead wanting us to increase this number by 8? Are they wanting us to do this first and then multiply that entire result by 5? Okay? And it's not clear, but if that's the way the writer wanted us to say it, they'd want us to add x and 8 first and then multiply by 5, so we'd be breaking the order of operations. So we'd want to put that x plus 8 in parentheses. Okay, so this is the answer to this question is part convention, but it actually makes a little bit of sense grammatically too. Okay, that if I want this to be the result right here, okay, then if you think about it, I would want to say, and you got to listen carefully, it's not going to be so obvious. I would want to say 5 times the number increased by 8. There's a slight pause right there, okay? Whereas to say the second phrase, I would want to say 5 times a number increased by 8, where there's no pause on this part of the phrasing. And remember, grammatically, what indicates a pause is a comma, okay? And so the way you actually get this settled is if I say 5 times a number and then pause, so use a comma, increased by 8, like that. This is the one that's going to translate to 5x plus 8, okay? But if I just write that whole phrase without a pause or without a comma, all right, the way I originally had it written, okay, then there's no pause, so it's 5 times the number increased by 8. So again, this is part convention, but you can actually kind of reason that out grammatically. So in this case, you would say 5 parentheses x plus 8. Okay, that is very tricky, and be very careful with it. But and I wish it were always so straightforward, because I've caught myself before. I write this, but I actually mean that. And but that's usually in my own writing. Whenever I'm writing for someone else, I try to be more careful. And so I'll be the first one to admit that that is tricky, and it's the good thing is that's the trickiest thing. We'll see here. All right, so let's practice translating some equations. Okay, so we're about to start translating to equations, and we have all the pieces that we need. Okay, remember that an equation is that two expressions are equal, and so we've just talked about how to translate expressions. So all that's going to be involved is we're going to have two expressions to translate, and then remember that an equation has an equal sign in it. Sometimes the wording will actually say equals. More often than not, it'll be indicated with the word is. And remember, that's an is that's by itself, not an is that's a helping verb. I know you're probably feeling like you're getting a little bit too much of a grammar lesson in this, but it ends up being important. And I'll go ahead and go on one of my tangents that please try to not get in your mind that words and math do not go together. They depend very heavily on each other. All math is, and all that symbolism is shorthand to basically prevent writing long phrases over and over. Okay, and so so we already have everything we need. All we have to do is isolate where that equal sign is. All right, and then the idea is that we'll find where we have that equal sign, and then we'll just have one expression to translate. And I don't know why I wrote them in backwards order, but we'll have the first expression to translate and the second expression to translate. And this is what we've already done. So the only new layer is isolating where that equal sign is in there. And then you can think about us math teachers being evil and getting two expression translation problems into one. Okay? And so let's look at some examples here. Okay, and so we're going to say to translate into an equation. Okay, like that. All right, so let me write a few, and then you folks that like to pause and practice can try them before I go through them. Okay, and so these are the first two examples, and then we'll do some more on the next slide too. So So, like I say, you folks that like to pause and try these, please do so now because I'm about to go through them. Okay, so here's our first one. Twice a number plus 7 is the number minus 8. So what I would encourage you to do first on these is find where the equal sign is. And so if you look carefully there, here is our is that's by itself in terms of verbs. And so that's where our equal sign is. Okay? Now what that allows you to do then is that allows you to isolate the two sides that you need to translate. So remember that now we just have two expressions to translate. And so here is our first expression to translate, and then here is our second expression to translate. Okay, it makes it a little simpler to do it that way. All right, and so now I just want to treat this like this is two problems from our last slide. And so I want to translate this one, or our last set of examples, I should say, and then I'm going to translate this one. Okay, so let's start here with twice a number plus 7. So remember, twice means to multiply by 2. Be careful about writing that as x squared. This is really 2x. Okay, like that. And then plus 7, so that would be 2x plus 7. Okay, like that. And then over here, now we just translate the number minus 8. So the number is our variable, and then minus 8. Okay, now be careful about this because most of you have done some algebra before and stuff, and we'll do this once we get into equation solving, but we haven't gone through equation solving yet. So this is going to be the answer. You folks that have done it before and want to practice, you can try to solve it and see if you can actually solve it, but be careful, especially in the homework and more especially on the test. This is the answer we're looking for right here, so make sure that's what you circle. If you go and try to solve it too, you can do that either on scratch paper or just make sure to have the actual answer to what you're being asked circled. Okay, all right, so now we're on this number 2 now, and so we need to try to find where the equal sign is. If you look at that carefully, here's your is. That's all by itself, so there's my equals. And see, this one's written as a row. On my first example, I wanted to make it a little easier, so I just wrote the minus 8 down here. Usually if you run out of space, you just keep going on the next line. So it's not so easy to draw an arrow here. Okay, but there's my equal sign. So I have this equals here. So then just try to isolate your two expressions. Okay, and so where are my two expressions? It's what's to the left of the is and what's to the right of the is. Let me use a different color for the second expression this time. Okay, so those are the two things. And so what I want to do is over here on the left, I want to translate the blue part. And over on the right, I want to translate, oops, I used a different color. If you don't know, I'm slightly colorblind, so sometimes I can't recognize what I used. But anyway, all right, and so now we just treat it like two expression problems, and we're ready to roll. So the first one that's in blue is the product of 6 and a number. So remember, what does product indicate? Hopefully you're taking notes and you can look back if you forget. But product indicates multiply, okay? And so we're going to be multiplying here. What two things are we multiplying? 6 and a number, so we'll use a variable for that, okay? Like that. And then the second one that's in red is the number subtracted from 7, or I'm sorry, the number subtracted from 12. Okay, this is one of those tricky wording ones. All right. We got subtraction. That part's fairly obvious. We have subtraction. But which order does the subtraction go? The number is being subtracted from 12. So we're starting with 12 and we're subtracting the number. So it's actually 12 minus x. Okay. Now, whenever you're multiplying a number times a variable, this is a perfectly fine form of the answer. You could stop there and answer. Okay, but to get you more used to math, just like up here we wrote 2x. Remember we use that idea they call juxtaposition. And so whenever we're multiplying a number times a variable, we usually use that juxtaposition idea. So the way most people would write this answer is sec x is equal to 12 minus x, like that. Okay, now like I say, me personally, I wouldn't take off if you wrote that as your answer. I'm just saying it's preferable, and that's more of what you'll see, and so that's kind of up to you. All right, so now let's look at this one. If you like to try beforehand, please pause it now. Okay, so this one says 12 times the number minus 8 is the quotient of the number and 3. Okay, and so here we have this, and again, key way to get started, at least in my opinion, is to isolate where the equal sign is. Where do we have the is by itself, at least in terms of verbs, is right here. Okay, so there's our equal sign right there. And then if you hopefully don't mind me using these colors here. And so then the first expression I need to translate is right here, okay? And the second expression I need to translate is to the right of that is, okay? Like that. So now we're just writing those two things equal to each other. And the key thing is here, I want to translate the blue part on the left, and I want to translate the red part over on the right. Okay, so now, this is one of those tricky ones. I don't know if you tried this beforehand. I wish I would have told everybody to try this. But 12 times a number minus 8. Remember that that's not exactly clear the way it's written. But the thing is, there's no comma there. And so we would actually translate that left part as 12 parentheses x minus 8. Okay, like that. All right, and then over on the right side for the red parenthesis part, the quotient, remember quotient means divide, but typically we use fractions, okay? And so it's the first number divided by the second number. And so the first number is the number, so that's the variable, x, and then divided by 3, like that. So that would be our answer, is 12 times x minus 8 in parentheses is x over 3. Now, maybe pause and think about here, what wording would I use if I didn't want the answer to have parentheses? And so that's when I would use that comma. So I would say 12 times a number, and then I'd want to pause there. And so there would be a comma, and then I'd say minus 8 is the quotient on down the line for the rest. The left side, I'm not going to write the whole thing there. Okay, so in that case, the answer is 12x minus 8 is equal to x over 3. Okay, so I wish it were cleaner, but it's just a convention that makes a little bit of sense grammatically and helps clear up the issue of when you want those parentheses and whenever you don't want those parentheses. Okay, one other small thing to mention, but people sometimes have trouble with it, okay? And I mentioned this early on, but the word of indicates multiplication, but it's usually reserved just for fractions and decimals, okay? So let me point out why it ends up being multiply. And so first of all, just think about what the answer to this is. What is half of 100, okay? What is half of 100? Well, that's equal to 50, right? Now, how did you get that 50? You did 100 divided by 2, probably. Okay? Now, remember, we can think about division as being a fraction, so that could just as easily write that as 100 over 2. Okay? But the key thing is, the phrasing started with the word half, but there's no half written anywhere in this calculation. So how can you force the half in there? This is a little bit tricky, like I say, but one thing you can do is just take my word. The word of means to multiply, okay? But I do like to explain where things come from, okay? If you think about how fractions multiply, I can think about it 100 over 2 as being 1/2 times 100 over 1, okay? Think about going backwards. If we started with this problem, I'd be multiplying two fractions, and I would multiply straight across and get this 100 over 2, which is what you did to get that answer, right? All right. Now remember that any number over 1 is just itself, so this is 1/2 times 100, okay? So now if we just take out all that explanation in between, half of 100, that's equal to, from that last line, that's equal to 1/2 times 100. So you can see that of is translating to multiply, okay? And it might seem a little bit silly that I'm doing all of this, But if you think about this phrase, 2/5 of 100, like that, then it's not so easy from that basic notion about what to divide by right here, because you have these two parts in your fraction. So it's not just a straightforward division right there. And so now that we know what of means, what is that going to translate as? 2/5 of translates to multiply. So I would do 2/5 times 100. Just as a little fraction review, why don't you make sure you can get that? All right, remember how we do this. This is times 1. We write it over 1 and we multiply straight across. That's 200 over 5. So that's 200 divided by 5, which is 40. All right, we'll do a couple of quick examples of translating some sentences with of, but then that'll be it. Now on that last slide, if you saw that little balloon come up about really of by itself, I actually inserted that after because I realized when I wrote this first example that the word of shows up somewhere else. So remember in those earlier examples we talked about the sum of or the difference of or the product of. So here we're talking whenever of means, I just realized that I hadn't really thought about it, but here's that of by itself. So we have two numbers and we have the word of in between them. But you got to be a little bit careful now that I realize whenever we talk about the sum of or the difference of things, then we're doing that the indicated operation. Okay, so anyway, just following our normal format. First we isolate where the equal sign is, okay, and it would be right here, all right, and then I have those two sides of my equation. There's this side and then there's this side right here, okay, and so now the first side, the blue side, is 3/4 of a number, all right, and just remember that of means multiply, so we got 3/4. I could say dot right there, or I could just write x, is the way most people would write that. Then we have our is, so we would say equals, and then the sum of, so we have a sum, okay, remember how we handle that phrasing with the sum of or product of. We find that and that separates the two things we're adding here, and so we have what two things are we adding? We're adding 1/2 and the number, like that. Okay, this is actually a pretty complicated equation to solve, but we'll talk later about how to actually solve it. All right, so again, and that's a good reminder, remember in this set of related homework, the whole point is just to get the equation. Don't worry about trying to solve it. Okay, now in the second one, we have 2/3 of a number. Oh, I'm sorry, I was getting ahead of myself. So first of all, where is the equal sign at? It's right here. And so if you end up liking to do this, where you break it into the two sides, here's my left side, here's my right side. Okay, so I have my equal sign now with the is, and so the right side is actually very easy. It's just the number, so we're just going to equal x. Okay, now we have 2/3 of a number, so 2/3 x times x increased by 4, so we have plus 4. I actually claim that's incorrect, though, so I was trying to throw one of those tricky ones at you. There's no comma here, right here. Okay, so if I wanted to multiply just the 2/3 times x, I would need a comma right there. But so I actually need parentheses around that. So that would be the correct answer on that one. Okay, so I'm going to leave it there. I know there's some tricky parts of this, and some of them I just realized as I was making the video, and I've taught this before. So, so yeah, just be careful. Take it a step at a time. Get down translating just expressions first, and then remember, once you get to translating sentences, it's just isolating that equal sign and then translating each side of that equal sign. All right, so I hope that helps, and let me know if you have any questions, and all the best.